Hello. Now we are going to start our new point, that is rate law. That is rate law. In last video lecture, we studied how to express rate of chemical reaction, average rate of reaction, and what is the concept of instantaneous rate of chemical reaction, and how to express instantaneous rate of chemical reaction. Now we are going to start our new point, that is rate law. Okay, suppose we have one equation, that is small a capital A plus small b capital B, which gives product. Small a capital A plus small b capital B, which gives product. Now capital A and capital B are the reactant. Capital A and capital B are the reactant, and small a and small b are the stoichiometric coefficient. Small a and small b are the stoichiometric coefficient. Suppose we have one equation, that is N2 plus thrice H2, which gives product. Okay, then the stoichiometric coefficient of nitrogen is 1. The capital A indicates nitrogen, capital B indicates hydrogen. Small a indicates 1, small b indicates 3. Okay, that is the exact meaning of small a, capital A, small b, capital B. Okay, small a, capital A, small b, capital B. Okay, then according to rate of chemical reaction, ROR is equal to, how to write it? Okay, a negative sign is added to the reactant side. Okay, minus, what is the stoichiometric coefficient? It is small a. According to rule, change in concentration of species is divided by its stoichiometric coefficient. Okay, so minus 1 upon small a delta in bracket A divided by delta T, okay, is equal to minus 1 divided by small b delta in bracket B divided by delta T. This is how to write rate of chemical reaction. Now, what is the meaning of rate law? First of all, point to remember that rate law, it is strictly experimentally determined equation. Rate law, it is strictly experimentally determined equation. Okay, then I am going to write rate law directly, because it is strictly experimentally determined equation. We can't solve, we can't find rate law because it is experimentally values. Okay, rate law is equal to K means rate constant, in bracket capital A, in bracket capital B, raised to the power, not small a, raised to the power small x and small y. Okay, you can ask me where, how x and y are there. Okay, now listen it carefully. In 11th standard, we studied law of mass action, where it suggests rate of reaction is directly proportional to product of active mass of reactant. In law of mass action, we have to write small a and small b are the stoichiometric coefficient regarding in bracket capital A and in bracket capital B. But in case of rate law, you have to write not small a is replaced by x and small b is replaced by y. Okay, It is strictly experimentally determined equation. Okay. Now let us move to the definition of rate law. Okay. Rate law, it is defined as it is experimentally determined equation which express how rate of reaction can depends on molar concentration of reactant. How rate of reaction is depends on molar concentration of reactant. याचा अर्थ असा होतो, रेट लॉचा अर्थ असा आहे एक्सपेरिमेंटल डिटरमाइंड क्वांटिटी आहे आणि जी काय सांगते की रेट ऑफ रिएक्शन मोलर कॉन्सन्ट्रेशन म्हणजे स्क्वेअर ब्रॅकेट मध्ये दाखवणार रेट ऑफ रिएक्शन मोलर कॉन्सन्ट्रेशन वर कसं डिपेंड आहे हे सांगते. रेट लॉ म्हणजे थोडक्यात असा एक्सपेरिमेंटली डिटरमाइंड इक्वेशन जे काय दाखवतं रेट ऑफ रिएक्शन मोलर कॉन्सन्ट्रेशन वर कसं डिपेंड आहे ते दाखवतं. ओके. इज कॉल्ड ॲज रेट लॉ. ओके. देन what is the symbol of rate constant? As we know in 11th standard, symbol of rate constant is K. Okay. Then what is the definition of rate constant? Where in bracket A, in bracket B, that is molar concentration of A and molar concentration of B is equal to 1. Okay, in unity, molar concentration of reactant A and reactant B is equal to 1 is called as rate constant. Okay, so I am telling the proper definition of rate constant. Rate constant is defined as molar concentrations of reactant and each reactant is taken in unity. Rate constant is defined as molar concentration of each reactant. Molar concentration of each reactant is taken in unity. Unity means is equal to 1. Molar concentration of A and molar concentration of B. These are the reactant is equal to 1. Hence rate is equal to K. Okay. This is the first definition of rate law, and this is the second definition of rate constant. I am telling you once again definition of rate law and definition of rate constant. So rate law, it is strictly experimentally determined equation which express how rate of chemical reaction is depends on molar concentration of reactant. Okay. And what is the definition of rate constant? It is defined as rate constant K. It is defined as molar concentration of each reactant. Molar concentration of each reactant is taken in unity. Is called as rate constant. Okay. आता तुमच्या मनामध्ये प्रश्न पडलाय नक्कीच. ओके. रेट लॉ एक्सपेरिमेंटली डिटरमाइंड आहे. मी तो लिहू शकत नाही, मी तयार करू शकत नाही. तुम्ही इक्वेशन जर मला दिलं याचा रेट लॉ लिहायला सांगितलं, मी लिहू शकत नाही, जगात कोणी लिहू शकत नाही. का? एक्सपेरिमेंटली व्हॅल्यू असतात ते बघून लिहिता येऊ शकतात फार. मग रेट लॉ बद्दल आपल्याला काय सांगता येईल अजून? तर आय वॉन्ट टू नो व्हॉट इज द मिनिंग ऑफ एक्स अँड वाय. व्हाय इट इज रिप्लेस्ड A and B. ओके. सो माझ्या स्टाईलला सांगतो. आता समजा तुम्ही काय करताय, चहा बनवता येतो चांगला. मग चहा बनवताना काय घेणार आहे तुम्ही? चहा पावडर घेणार आहे. 10 ग्रॅम चहा पावडर घेतली, बरोबर. बाकीचे इन्ग्रेडियंट टाकले, बरोबर. तुमच्या हिशोबानुसार तुम्ही अशी मला तुमच्या समोर चहा तयार होते, बॉईल होते, कपात होते पर्यंत तुम्हीच बघताय. तुम्ही याची गॅरंटी देऊ शकता का की 10 ग्रॅम मध्ये जे टी पावडरचे पार्टिकल्स आहेत, 10 ग्रॅम मध्ये जे टी पार्टिकल्स आहेत त्या प्रत्येक कणानं प्रत्येक पार्टिकल्सनं चहा बनवण्यामध्ये कॉन्ट्रीब्युशन केले, पार्टिसिपेशन केले. त्याची गॅरंटी तुम्ही देऊ शकताय का? नाही देऊ शकत. तुम्हाला मॅन्युअली तुमच्या समोर असला तरी तुम्ही नाही सांगू शकत की बाबा 10 ग्रॅम चहामध्ये, चहा पावडरमध्ये बाबा 1,00,000 कण असतील, बरोबर. 1,00,000 कणांनी भाग घेतला रिएक्शन मध्ये नाव सांगू शकत तुम्ही, बरोबर. तुम्ही म्हणजे ते कसं मोजलं पाहिजे, मला एक्सपेरिमेंटली मोजलं पाहिजे ना. मग तसंच आहे रेट लॉचं. इट इज एक्सपेरिमेंटली डिटरमाइन्ड क्वांटिटी which express how rate of reaction depends on molar concentration of reactant. Okay, now अजून क्लॅरिफाय होण्यासाठी अजून एखादं एक्झाम्पल सांगतो. I don't have any problem with that. Okay, let us take another example of N2 plus thrice of hydrogen which gives twice of ammonia. Okay, then what is the stoichiometric coefficient of nitrogen? It is 1. It is 3. Okay, according to law of mass action in 11th standard, you write here rate is equal to K. Okay, in bracket N2, that the stoichiometric coefficient that is 1, in bracket S2 stoichiometric coefficient that is 3. Okay, but it is true for only law of mass action, not true for rate law. Rate law is given by, according to rate law, it is given by K is equal to N2 to the power X and H2 to the power Y. Okay, अजून म्हणूया 1 मोल नायट्रोजन आहे. नायट्रोजन means atomic weight of nitrogen is 14, then 2, 14 into 2, 28 grams. 28 grams of nitrogen are there. Hydrogen, atomic weight of hydrogen is 1, then 3 into 2, 6 gram of hydrogen. Total 28 plus 6, that is 34 grams of reactants are there. Okay, मग तुम्ही सांगू शकताय मला डायरेक्टली तुमच्या समोर आहे, तुम्ही घेतलं, सांगू शकता का 34च्या 34 ग्रॅमनी रिएक्शन मध्ये कॉन्ट्रीब्युशन केले? याची गॅरंटी देऊ शकताय का? तुमच्या डोळ्यासमोर रिएक्शन चालू आहे, तसं तुमच्या डोळ्यासमोर चहा बनवायचं चालू होतं, नाही सांगू शकत, बरोबर. याचा अर्थ तुम्हाला हे जो प्रॉपर एक्सप्लेनेशन देऊ शकत नाही, बरोबर. त्यातलं बाबा 34 पैकी 32.5 न घेतलं असेल, 33.2 न घेतलं असेल, 33.010 न घेतलं असेल, म्हणजे ही व्हॅल्यू एक्सपेरिमेंटलीच येणार का नाही. म्हणून रेट लॉ इट इज एक्सपेरिमेंटली डिटरमाइन्ड क्वांटिटी आहे. ओके, म्हणून ए आणि बी किंवा 1 आणि 3 च्या रिप्लेसमेंट मध्ये मी एक्स आणि वाय लिहिलंय, अलग लक्षात. म्हणजे मी रेट लॉ डायरेक्टली लिहू शकत नाही, मला लॉ ऑफ मास ऍक्शन लिहिता येतं कारण इट इज स्ट्रिक्टली बेस्ड ऑन स्टोइचियोमेट्रिक कोएफिशिएंट. बट आय कॅन नॉट राईट rate law by using stoichiometric coefficient. X and Y are not necessary to be the stoichiometric coefficient of the reaction. Okay, हे झालं rate law चं proper explanation. Okay, now let us take another example. Now let us take another example for rate law. Now which example I can write? Now hydrogen peroxide twice H2O2. Decomposition of twice H2O2 hydrogen peroxide decomposition केलं काय बनणार? First of all, it gives water plus oxygen. How what is the stoichiometric coefficient of water? Equation is not balanced. And twice H2O, okay, then it is balanced. Hydrogen 4, oxygen 2, 4. Okay. Then according to rate law, रेट लॉ कसा लिहायचा आहे बघा. रिएक्टंट कोण आहे? -1/2 रेट ऑफ रिएक्शन सारखंच आहे, -1/2 डेल इन ब्रॅकेट H2O2 डिवायडेड बाय डेल T. ओके, इज इक्वल टू K in bracket H2O2 to the power 1. हा रेट लॉ इथं मी लिहिलाय टोटली. ओके, तुम्हाला हा वाटेल की बाबा इथं स्टोइचियोमेट्रिक 2 इथं 2 नाही तर एकच आहे. याचा अर्थ 2 पार्ट पैकी एकानंच भाग घेतला असेल रिएक्शन मध्ये. 40 लोक स्पर्धेला इच्छुक असतील, त्यातले 20 लोकांना संधी मिळाली असं. ठीक आहे, म्हणजे Rate law, it is strictly experimentally determined equation. Rate law, it is strictly experimentally determined equation which express how rate of reaction can depends on molar concentration of reactant. मोलर कॉन्सन्ट्रेशन ऑफ रिएक्टंट. आणि तुम्हाला काम एवढंच करायचं आहे, रेट लॉ तुम्हाला दिला जात नाहीये, तो क्वेश्चन पेपर मध्ये ऑलरेडी न्यूमेरिकल सॉल्व्ह करण्यासाठी प्रोव्हाइड केला जातो. तो 1 आहे का 1.2 आहे काय असेल ते अलग लक्षात. तो एक्सपेरिमेंटली व्हॅल्यू आहे हे लक्षात ठेवा. त्याच्यानंतर आय एम टेकिंग अनदर एक्झाम्पल फॉर कॅल्क्युलेटिंग रेट लॉ. लेट अस से NO2 plus CO. I am taking a simple example. NO2 nitrogen dioxide gaseous phase, carbon monoxide gaseous phase. What is the product? One oxygen is go there. So CO2, it is gas, plus NO, it is also gas. Okay. Then what is the rate law? I am not able to write rate law because no one able to write rate law directly, because it is strictly experimentally determined the quantity. Then rate law is found to be K in bracket NO2 to the power 2. Okay, that's it. It indicates rate of reaction can't be depends on carbon monoxide. Okay, rate of reaction only depends nitrogen dioxide. Okay, it is strictly experimentally determined equation. So nothing to worry about that. Okay, this is how to write rate law. Okay, then I want to know some other examples like, I am telling the examples like what is the meaning of x and y. What is the meaning of x and y in the given rate law? So x and y are not the stoichiometric coefficient. X and y are not the stoichiometric coefficient. Okay, it is value, it is depends on experiment. Okay. Then x and y are small integers. Understand? Integers. It may be 0 or also in complex reaction. It is also in fraction. In complex reaction, x and y are also in fraction, like 1/2, 3/2. Okay. Then x and y indicates effectiveness. X and y indicate effectiveness of concentration of reactant. X and y indicates effectiveness of concentration of reactant. Okay. Then suppose in x and y, x is equal to, let us consider, these are the three basic points. Please take a screenshot of this. Okay, now I am telling once again, x and y are the stoichiometric coefficient. No, x and y are not the stoichiometric coefficient. It is not depends on a and b. Okay, it may be x and y may be small integral like 0, 1, 2, 0, 3, like 1, 2, 3, 4, 5, 0, maybe fraction. Okay, or sometimes x and y may be in negative. Sometimes x and y may be in negative numbers. Okay, if x and y, what happens if x and y are the negative? Okay, if x and y are the negative, then value of rate of reaction are decreases. X and y म्हणजे मोलर कॉन्सन्ट्रेशन आहे. एक्स अँड वाय कमी असते तर रेट ऑफ रिएक्शन कमीच होणार, बरोबर काय. एक्स अँड वाय जर वाढले तर रेट ऑफ रिएक्शन वाढली, पैसे वाढले की श्रीमंतीच वाढते ना, बरोबर. तसे एक्स अँड वाय निगेटिव्ह असतील तर रेट ऑफ रिएक्शन ची जी व्हॅल्यू आहे ती डिक्रीज होते. ओके, नाउ आय एम टेकिंग वन अनदर एक्झाम्पल. तुम्हाला कसं एक्झाम मध्ये किंवा क्वेश्चन पेपर मध्ये किंवा सरावासाठी बुक मध्ये एक्झाम्पल दिलेली असतात, त्या पद्धतीचं एक छोटस बघा. सपोज ए प्लस बी विच गिव्स प्रोडक्ट. ओके, क्वेश्चन पेपर मध्ये याच दिलेलं जाते. अँड रेट लॉ इज फाउंड टू बी असं म्हणतात. रेट लॉ इज फाउंड टू बी रेट इज इक्वल टू के in bracket A in bracket B, and value of x is equal to 1 and value of y is equal to 2. Value of y is equal to 2. Then you can write rate law. रेट लॉ या रिएक्शनचा रेट लॉ असा फॉर्म झालाय आणि या तुम्हाला व्हॅल्यू दिलेली आहे, बरोबर. त्याच्यावरून तुम्ही रेट लॉ लिहायचं आहे. आता रेट लॉ याला डोकं चालवायचं नाहीये काय, बघा ना. रेट इज इक्वल टू के ए टू द पॉवर काय होती, इथं काय ना म्हणजे एक्स होतं नाही तर वाय होतं. एक्स ची व्हॅल्यू 1 आहे म्हणजे तुम्ही 1 लिहितो ना लिहिले तर चालतंय. इन ब्रॅकेट बी टू द पॉवर वाय ची व्हॅल्यू 2 आहे म्हणजे इथं वाय असते. हे झालं, संपलं एक्सपेरिमेंटल रेट लॉ. झालं 1 मार्काचं न्यूमेरिकलची जोडणी झाली. ओके, इतकं सोपं आहे. त्याच्यानंतर नेक्स्ट, सपोज A and B which gives product. A and B which gives product. Rate law is found to be K in bracket A in bracket B. The value of x is equal to 0 and value of y is equal to 2. Then write rate law. Okay, the answer is rate is equal to k a to the power 0 because here are the x and here are the y. A to the power 0 and b to the power, the value of y is 2, b to the power 2. This is how to write rate law because it is experimentally determined equation and we are nothing to do or nothing to change with rate law because already it is given in the exam. Okay, this is how to write rate law. Okay, hopefully you will definitely understand that is the point of rate law. Okay, our next point is order of reaction. Order of reaction. Order of reaction. Okay, order of reaction and rate law are the correlated with each other. These are the 2 points are the correlated with each other because it is also experimentally determined equation as like rate law. Rate law and order of reaction are both experimentally determined quantities. So, what is the definition of order of reaction? The order of reaction, it is sum of power of concentration of reactant. It is sum of power of concentration of reactant is called as order of reaction. Now, I am taking one example to understand order of reaction. Suppose A plus B which gives product. A plus B which gives product. Okay. Now, rate law is found to be. Rate law तुम्हाला काढायला दिलं जात नाही. Is found to be k is equal to a to the power 1 and b to the power 1. Then calculate order of reaction. Okay. Now let us see the definition of order of reaction. Sum of power of concentration of reactant. These are the reactant. What is the power of that particular reactant? The power of particular reactant is 1 and power of B is 1. Okay. Then sum 1 plus 1. Order of reaction, that is in second order. Okay. It is so easy to write order of reaction because only summations are there. It is really very easy point. Then I am telling another example. Sum of power of concentration of reactant is called as order of reaction. And then suppose A, which gives product. Okay. Then rate law is found to be. K A to the power 1. What is the order of reaction? Sum of power of concentration of reactant. रिएक्टंटचं जे कॉन्सन्ट्रेशनची पॉवर जी आहे म्हणजे बेरीज करायची. किती? फर्स्ट ऑर्डर. Okay. I am taking this example. Rate law, A which gives product. Rate law is found to be K in bracket A to the power 0. What is the order? That is zero order reaction. Okay. Like rate law, order of reaction is also experimentally determined quantity. Okay, so nothing to do with order of reaction, just take a sum. Okay, now let us move to the perfect example. Now what is the hydrogen plus combination of iodine which gives twice of HI? Okay, rate law is found to be rate is equal to K in bracket H2 in bracket I2. Okay, then H2 1 I2 1. What is the order of reaction? Sum of power of concentration of reactant. Concentration of reactant is always expressed in square bracket. Summations are the 1 plus 1, that is second order. Okay, this is how to write order of reaction. Only बेरीज फक्त करायची हो. Okay, then I am taking another example like NO twice NO plus O2 which gives twice NO3. Equation balance आएगा 2 into 2 to 4 twice NO2 plus O2. Okay, then 4 into 2 6. Okay, twice NO2 twice NO plus twice O2 which gives twice NO3. So rate law is found to be rate is equal to K means rate constant, NO to the power 2 O2 to the power 0. What is the order of reaction? 2 plus 0, that is second order. It indicates reaction doesn't depend upon concentration of oxygen because the order of oxygen is 0. The order of oxygen is 0. Second order with respect to NO, 0 order with respect to O2. Then overall order of reaction is 2 plus 0, that is second order. The meaning of that particular reaction is doesn't depend on concentration of oxygen. Okay, that is a really very easy point to write order of reaction. Okay, now order of reaction, it may be 0 or it may be in fraction. Okay, sometimes maximum order, that is third order, but sometimes I am taking another example, that is the given equation contains fourth order, but there are some rare examples. Okay, now I am telling the decomposition of acetaldehyde CH3CHO which gives What is the CH4? Hydrogen परमाणु ना, CH4 plus carbon and oxygen, CO. Okay. Rate law is found to be rate is equal to K in bracket CH3CHO to the power 3 by 2. Okay, what is the order of reaction? That is 3 by 2 order. 3 by 2 order. म्हणजे मला तुम्ही सांगा, तुम्ही रेट लॉ आणि ऑर्डर ऑफ रिएक्शन मध्ये काय केलं स्वतःच लोक लावू शकत नाही आपण, कारण की एक्सपेरिमेंटली डिटरमाइंड क्वांटिटीज आहे, बोथ आर द एक्सपेरिमेंटली डिटरमाइंड व्हॅल्यूज. सो रेटला एक्सपेरिमेंट दिला जातो आणि त्याच्यावरनं ऑर्डर लिहायची. ऑर्डर लिहायची म्हणजे काय, फक्त बेरीज करायची, जी काय पॉवरची बेरीज असेल ती करायची. ओके, दॅट इज कॉल्ड एज ऑर्डर ऑफ रिएक्शन. इट इज रियली व्हेरी इम्पॉर्टंट अँड इझी पॉइंट, ऑर्डर ऑफ रिएक्शन. ओके, in next video lecture we are going to start the new point, that is molecularity and rate law, integrated rate law, first order and zero order. Okay, hopefully you have understood this. Thank you.